Good evening, and welcome back. Today we're going to walk, carefully and critically, through one of the more haunting iron ghosts of the Second World War, the Panzerkampfwagen E-100. This isn't a glorified tank story. It's a story about ambition, engineering audacity, and the strategic costs that follow when politics, industry, and warfare collide. Over the next hour, over the next 20 to 30 minutes, I'll lead you through 7 focused segments: the Haustenbeck Discovery, the Einheitsfahrgestell vision, the design contest between Adler and Krupp, the E-100's engineering paradox, the strategic opportunity cost, the British FVRDE assessment at Chobham, and finally, the legacy this Leviathan left for post-war armored doctrine. Ready? Let's begin. Segment 1. The Haustenbeck Discovery. In April 1945, British forces moving through northwest Germany came across an almost surreal sight: an unfinished, hulking silhouette of what would later be identified as an E-100 hull, abandoned in a compound near Haustenbeck. The scene, frozen steel, open hatches, incomplete fittings, wasn't cinematic fantasy. It was industrial reality. The hull had been stripped of many components, yet its sheer size evoked questions. Why build this? Who decided it was necessary? And crucially, why stop? The discovery mattered less because the British found a treasure, and more because that scrap answered a different question. What does unchecked engineering ambition look like at the end of a war? The E-100 was not a fielded weapon. It was an idea solidified in steel. To understand it, we must step back to 1943 and look at the German industrial crisis that birthed the E-series idea. Segment 2. The Einheitsfahrgestell vision. By 1943, German armored production was fragmented, inefficient. Tiger, Panther, and myriad variants all demanded different parts, training, and maintenance. The Heereswaffenamt proposed the Entwicklung series, the E-series. The aim was deceptively simple: standardize components across weights and rolls, simplify production lines, and reduce the logistical headaches choking the Wehrmacht. It was a rational response to a chaotic industrial reality. But standardization on paper is different from standardization in the furnace of war. The E-series envisioned modular chassis, an Einheitsfahrgestell, to be scaled for light, medium, heavy, and super-heavy rolls. In theory, a single set of subassemblies could be adapted upwards, allowing firms to produce at scale. In practice, wartime material shortages, bombing of factories, and competing design philosophies made that neat, modular dream very messy. The E-100 emerged as the super-heavy node of that vision, a testbed for how far German engineering could push a standardized chassis concept toward extremes. Segment 3. Adler versus Krupp. Here is where politics and philosophy meet the drawing board. Two camps formed, one pushing for maximalist, nearly symbolic showcases of power, think Maus and similar concepts, and another advocating for pragmatic, streamlined solutions that accepted limits. Adler and Krupp represented these poles in the contest over the super-heavy remit. Adler's proposals tended toward elaborate armor and heavy armament. Krupp's designs sought a tempered balance, though still pushing mass and protection far beyond typical tanks. The arguments were not just academic. If you accept Adler's maximalism, you commit to vehicles that absorb enormous resources per unit, require unique transport and recovery solutions, and, critically, may never be deployable in significant numbers. If you accept Krupp's more pragmatic leanings, you still commit to something almost unworkable, but perhaps marginally less so. The E-100, with Krupp's involvement, was the compromise.
Less gargantuan than the Maus in theoretical weight, but still a super-heavy class vehicle that required answers to questions the Reich could no longer solve by 1944.
Segment 4. The Engineering Paradox. Now we get into the meat of the machine. The E-100 incorporated some innovative ideas, notably the proposed use of Belleville washer spring elements in its suspension system. Belleville washers, conical spring washers, offer high spring rates in compact stacks. For an enormous vehicle, they promised reduced space consumption and theoretically better ground contact behavior. On paper, they could lower the number of large exposed coil springs and allow for a cleaner, protected suspension layout.
But here's the paradox. Innovations that seem to solve one problem often expose others. The Belleville arrangement could concentrate stresses on track links and hull mountings, and replacement under field conditions would be difficult. Imagine, no pun intended, servicing a stack of conical washers under enemy fire. Then there's the proposed power plant, the Maybach HL-234, an advanced engine concept. The HL-234 promised higher specific power, but development was delayed, and fuel quality, production capacity, and the complexity of coupling such an engine to a drivetrain for a 100-plus-ton vehicle presented severe practical limits.
Right.
Let me expand. Ground pressure calculations for the E-100 suggested it could be comparable to lighter tanks if wide tracks were fitted, but that demands huge track manufacturing output, exactly what Germany lacked late in the war. Moreover, the heavier the vehicle, the more power you need, the more fuel you burn, and the thicker the roads and bridges you destroy under its weight. Theoretical ground pressure gains are meaningless if the infrastructure collapses beneath you. Segment 5. Strategic Opportunity Cost. This is the painful part. Every ton of armor, every hour of skilled labor, every factory retooled for an E-100 was a ton not spent on Panzer IVs, Panthers, or anti-tank guns that were actually being fielded and used. A super-heavy program is the epitome of sunk cost fallacy. Once resources have been poured in, political and industrial inertia makes cancellation morally and bureaucratically difficult. The Reich continued the program long after it was strategically rational to do so, because the program had become invested with prestige, perceived technological pride, and bureaucratic momentum. Consider the scale. Shifting resources from dozens of deployable medium and heavy tanks into a handful of prototypes offers a dramatic negative return in wartime utility. The E-100 is a case study in how strategic aims, winning battles, securing lines of supply, were overshadowed by industrial prestige projects. It's not merely that the E-100 wouldn't have changed battlefield outcomes, it's that prioritizing it actively worsened Germany's capacity to fight with effect in 1944–45. Segment 6. The FVRDE Technical Assessment. After the war, British engineers at the Fighting Vehicles Research and Development Establishment, FVRDE, at Chobham inspected captured examples. Their analysis was frank. The E-100 incorporated some genuine engineering innovations worthy of study, but it was an operationally naive design. Components were overspecified in some places and undersupported in others. The hull found at Haustenbeck offered a practical insight. Here was a machine that could be analyzed and measured, but not one that offered credible prospects for mass deployment. The British report did more than catalog parts. It placed the E-100 in context. It evaluated material quality, armor layout, potential mobility envelopes, and, importantly, maintainability under combat conditions. Their conclusion was blunt: innovative, intellectually interesting, but operationally impractical.
They contrasted it with the more resilient design philosophies that favored maintainability, repairability, and throughput, principles that would inform later British and Allied armored doctrine and tank design. Segment 7. Legacy of the Leviathan. So, what does an unfinished hull teach us? First, it emphasizes that sheer engineering excellence does not equate to military effectiveness. The E-100 taught the post-war world a lesson already obvious in retrospect. Mobility, logistics, and numbers often trump exceptional specifications. Second, it created a post-war curiosity that fed into armored vehicle study programs. Elements like suspension analysis, armor shaping, and crew ergonomics were re-examined with an eye for what to keep and what to discard. By the way, some of the suspension thinking, compact high-rate springs, attention to protected components, found echoes in later designs, not as wholesale transfers, but as ideas reinterpreted within more balanced doctrines. The E-100's greatest legacy may be as a cautionary tale. That technical novelty divorced from operational reality can be seductive but ultimately self-defeating. Now, I want to unpack a few detailed technical points that readers and engineers often ask about. First, armor layout. The E-100's frontal geometry showed attempts to combine thickness with sloping to maximize effective thickness without extravagant mass increase. But this is theoretical math. The marginal gains from slope are offset by the simply brutal increase in weight required to achieve protected area sizes useful in combat. Second, armament. There were unresolved debates about turret configurations and main guns. Whether to mount an extremely large gun to justify the weight, or to accept a more moderate armament and thus a more practical vehicle. That debate went nowhere in the end. Here's the key. Weapons are tools. A bigger tool isn't necessarily better if it can't be wielded. Let's discuss logistics in a bit more granular way. Fuel consumption scales non-linearly with weight and terrain. In many theaters, Eastern Front mud seasons, the crumbling bridges of Western Germany, a single E-100 would have required dedicated recovery and road repair units. Rail transport was another bottleneck. Railway bridges and tunnels often couldn't accommodate super heavy loads without special preparations. In short, the E-100's operational footprint would have been enormous long before it saw combat, if it ever did. There's also the human factor. Crew size, visibility, and internal ergonomics matter. Reports from British inspections suggested cramped maintenance access and crew stations that, while shielded, prioritized armor over effective situational awareness. In modern armored doctrine, the balance tends toward crew survivability through mobility and situational command rather than simply adding more steel around an under-supported crew module. Before closing, a quick comparative thought. The Allies largely converged on the principle that medium-weight main battle tanks, capable of combined arms operations and quick logistical cycles, provided much more sustained combat value than isolated super-heavy beasts. The E-100 and Mouse projects stand as counterexamples, engineering exercises that failed the gauntlet of real war requirements. So, what are the takeaways? 1. Engineering ingenuity is necessary but not sufficient. 2. Standardization initiatives like the Entwicklung series were rational responses to industrial stress, but execution matters, and wartime realities can overwhelm the best-laid plans. 3. The E-100 was in many ways the product of a late-war system trying to assert control through technical showpieces rather than through practical force multiplication. And 4. Post-war analyses, particularly by the British FVRDE, turned the E-100 into a learning artifact, useful in research, ineffective as a weapon. I'll end with a final image. That hull at Haustenbeck, half-built, open to the air. A massive shell on a muddy compound. It was, and remains, both a monument to extraordinary technical ambition and a warning. In war, the utility of a machine is measured not by its specifications on paper, but by its ability to contribute to effective, sustainable combat operations. The E-100 ticked many boxes on technical paper, but failed the real test, feasibility within a functioning strategic framework. The E-100 was, in many ways, the product of a late-war system trying to assert control through technical showpieces rather than through practical force multiplication. And 4. Post-war analyses, particularly by the British FVRDE, turned the E-100 into a learning artifact, useful in research, ineffective as a weapon. Thank you for listening. If you have questions, technical, strategic, or archival, I'll take them now. Ask about suspension specifics, the Maybach power plants, the FVRD measurements, or the political infighting that kept these projects alive. I'm happy to dig deeper.